Hi, this is Raphael Mudge, the creator of Cobalt Strike. Welcome to part 3 of Advanced Threat Tactics, Targeted Attacks. In this lecture, we're going to talk about how to get a foothold in a modern enterprise by executing a targeted spear phishing attack with Cobalt Strike. We're going to talk about client-side attacks and why they matter. We're going to go through how to conduct reconnaissance with the system profiler. We're going to go through Cobalt Strike's attack options. We're going to talk about how to deliver a beacon with a Metasploit framework exploit. And I'm going to take you through Cobalt Strike's spear phishing workflow as well. So what is a client-side attack? A client-side attack is an attack against an application used to view attacker-controlled content. You may be asking, why do we do client-side attacks? Well, it used to be, if you wanted to break into a network, you would scan it from the outside, find something that was a vulnerable service, and try to exploit it. Okay? The world has moved on. It has done a good job at mitigating those kinds of problems, and there's very little low-hanging fruit left in that particular space. So attackers have moved on to client-side attacks. They've moved on to client-side attacks because there's not as much attack surface in front of the firewall as there used to be. Attackers have found it's a lot easier to go around the firewall by sending an attack package to the target, and if they open the attack package, the attacker's malicious package then has an opportunity to attack that target system, and if it succeeds, the target can connect back to you, the attacker, through the target's firewall. This is why we do client-side attacks. Now you may be asking, how do you get a foothold this way? Well, here's my process. Step 1, I like to understand the target's environment as much as possible, okay? Every offensive action really does begin with reconnaissance. And that reconnaissance can be something active, like a system profiler. It can also be open source information gathering, or it could even be a trusted agent helping you save time by feeding you information. Step 2, you're going to want to take the information from your reconnaissance phase and create a virtual machine that mirrors your target environment as closely as possible. This includes patch level, antivirus, and as many applications and version numbers matched as closely as possible. Okay? Step 3, you're going to attack that virtual machine and use it to select the best possible attack situation or best possible attack option for your situation. Okay? Once you've decided which attack you want to use, next, you're going to stand up your infrastructure and you're going to try to clone the attack, you're going to try to dress up the attack to make it match whatever pretext or ruse you have to get the user to believe that your attack is indeed some legitimate order of business. Step 5, you're going to take your carefully crafted attack package, deliver it to your target, and if you paid very close attention to all the details in each of these phases, your likelihood of success goes up dramatically. Now let's talk about client-side reconnaissance. A technology in Cobalt Strike for client-side reconnaissance is the System Profiler. This is a web application that the target has to visit. Once the target visits it, the System Profiler will do what a good web analytics package does, and it will pull information down about the target. It'll query for different browser plugins. It'll try to discover different applications, all through the information that the browser makes available. It will also try to decloak the visitor's internal IP address. If you want to learn more about what's possible by interrogating a visitor's browser, I encourage you to visit browserspy.dk. Okay, let's take a look at the System Profiler. Here we are in Cobalt Strike, connected to a team server in Amazon's Elastic Computing Cloud. Let's go ahead and stand up the System Profiler. Go to Attacks, Web Drive-By, System Profiler. What we're going to do is put in our address, our fully qualified domain name for this team server, which is ads.losenolove.com. And we're going to make it redirect anybody who visits it to linkedin.com. Okay? So just like that. Cool. I highly recommend that you uncheck the Use Java Applet to Get Information box because, well, 2 years ago, that applet was really useful. Java in the browser without a code signing certificate has since become quite useless. Okay, let's go ahead and press launch. And we now have the System Profiler running on ads.losenolove.com. Okay, cool. Now, a couple of things to know. First, View Weblog is where any hits on the web server will show up. Okay? View Applications is where all the information from the System Profiler will show up. Finally, if we go to Cobalt Strike Visualization Target Table, any targets that get added to Cobalt Strike's data model will show up here, okay? So 3 places to look when doing reconnaissance actions like the System Profiler. Let's go ahead and give it a try. Let's surf to the System Profiler in Microsoft's Edge browser in Windows 10. We'll go to ads.losenolove.com/in/, and you can see it's at linkedin.com. Now, this is a relatively clean Windows 10 system, but here you can see some of the information we were able to get back. Okay? And there's our hit in the weblog. And the event log tells us we gained a profile. And of course, we see a host pop up into our data model as well. Cool. Let's go ahead and try another system. Let's pull up a Windows 7 system. We'll try Internet Explorer. This one's a little bit more dated in its patch level. So let's go to ads.losenolove.com/in. And same thing, you can see I'm at linkedin.com. Very cool. And let's try one more system. Okay, so we'll go ahead and close that. Let's try this one with Google Chrome. And we'll try it with Internet Explorer as well. And you'll notice we're seeing the same external address for these systems. And the reason behind that is we're going out to the internet doing this. So all Cobalt Strike can see is the one point of presence where these systems are coming from. So there's ads.losenolove.com, and we're back at LinkedIn. That's Google Chrome. And let's come over here and try the same thing with Internet Explorer. Okay. And if you're really curious, I'll try the same thing from my Macintosh as well, just so we can get some good variety in our diet, if you will. So let me just pull up Firefox on a Macintosh. And we should have a Macintosh show up as well. Cool. So there we go. We now have a bunch of system profiles to look at. Let me give you a little bit of a tour of this information. Okay? First, you can see the information we were able to gather from each system that hit. You can also set a note on these as well. Like I'll say this is Raphael's Mac. Okay? Now these systems all have, they kind of blend in a little bit because of the same internal address of unknown. But if you look at the date and timestamp, you can tell them apart by this information. Okay? So let's go ahead and go through these real quick. This is the Windows 10 system, and this is the Windows 7 system with Internet Explorer, Windows 7 system with Google Chrome, and Windows 7 system hit with Internet Explorer. Different browser configurations are going to give us different information. But a few things I want you to know. If you see a *64 next to an application, that means the system profiler has detected that the user is using a 64-bit version of that program. Okay? With Internet Explorer, if you see this JScript line, that 18015 is the build number of the JavaScript engine in Internet Explorer. You can actually map that number back to a patch level for that system, in particular for Internet Explorer. So if you want to know if they're up to date on patches, use this information right here. And in some cases, with some browser configurations, the profiler is able to decloak the internal address. It all depends on the system's patch level and which browser the user happens to be using. Okay, now that we've conducted our reconnaissance, let's talk about our attack options. I prefer to use what are called user-driven attacks. A user-driven attack is not an exploit. A user-driven attack is an attack that takes advantage of built-in functionality in a client-side application. The downside to a user-driven attack is it usually requires fooling the user into taking some action that is favorable to us, the attacker. That said, user-driven attacks have many benefits. First, they're not seen as malicious, so they're very unlikely to get patched. Next, user-driven attacks, because they are built-in functionality, work across a wide variety of versions of whatever application you're targeting. Next, user-driven attacks are pretty awesome because they're very reliable. Once the user takes the action needed to trigger the attack, it's just as good as if the user had run an executable or taken some action to put your malware on the box. You don't have to worry about all the pain that goes with memory corruption, okay? So I am a big fan of user-drivens. Cobalt Strike gives you several user-driven attack options. There's the HTML application. This is an HTA file that can use a PowerShell one-liner to get a payload into memory, or drop an executable to disk and run it. There's the Java signed applet attack. This is a Java applet. It gets embedded into a website, signed with a code signing certificate. Okay? The Java signed applet attack prompts the user and asks them if they want to allow the attack to run. If they do, they've just given you free code execution on their system. There's also the Microsoft Office document macro. This is a macro that embeds into an Excel spreadsheet or Word document, and if the user allows it to run, they've just given your payload a free pass into memory. There's also the PowerShell web delivery attack, which is a PowerShell one-liner that if you can get the user to run it or embed it into something else that runs it for you, this will download your payload and inject it into memory. Finally, there's the Windows dropper. This is an executable that drops a document to disk, opens it, and executes your payload in the background. Okay? The Windows dropper is pretty effective if you take the steps to disguise it by changing its icon to look like a document. It's particularly effective with out-of-band delivery techniques that don't involve email. Things like mailing a CD to your target. The HTML application is the new user-driven. I shouldn't say new, it's been around forever, but it's the user-driven that many pen testers are gravitating towards today. HTML applications aren't very common out in the wild, so I think personally that this attack does not have a lot of life left. I could be wrong, but whatever. Let's talk about the Java signed applet attack. The default version of this attack in Cobalt Strike uses a self-signed code signing certificate, okay? That self-signed certificate will not work in any Java update since January 2014. If you're going to take advantage of this attack, you have to purchase a code signing certificate and use it to sign Cobalt Strike's applet attack. We'll talk more about that in part 9 of this course. The Microsoft Office document macro is today one of my favorite attacks still, okay? So that's a good attack to use. Okay, let's take a look at a user-driven attack in Cobalt Strike, okay? First things first, I'm going to go back to the table view for my sessions so I can see any new beacons that come in, okay? Now, Cobalt Strike's user-driven attack options are available under Packages and Web Drive-By. Later on, in part 9 of this course, I will show you the signed applet attack, and I will show you the Microsoft Office macro. For now, let's go ahead and take a look at the HTML application. So tax packages HTML application, and we get the option to generate an HTML application that runs our payload with an executable or PowerShell. We'll use PowerShell, and let's go ahead and create a listener real quick. We're going to call this EC2 beacon HTTP. We'll put in our address, which is ads.losenolove.com, port 80. Press save, and we'll have it beacon back to ads.losenolove.com. Cool. Let's go ahead and press generate, and it's going to ask us where to save this file, and we'll call it updates.hta. Why not? And there we go. Now, we need to get this HTML application to a target. Let's go ahead and host it on Cobalt Strike's web server. Let's go over here to this link, and we'll navigate to updates.hta, and we'll host it as updates.hta. Very cool. Let's put in ads.losenolove.com as our local host, hit launch, and there we go. We now have a URL that a target can surf to pull down this HTML application attack. Let's come over here to a target system, pull open a browser, and let's surf over to this HTML application and press run. And it's going to ask if we want to run it. Sure. But there you go. You can see in Cobalt Strike that we have a foothold in this network on this Windows 10 system. So that's an example of the HTML application attack. On top of the different user-drivens, Cobalt Strike also generates executables and DLLs that get your payload into memory. Use attacks packages Windows EXE to generate an executable or DLL with a payload stager inside of it. Use attacks packages Windows Executable S to generate an executable or DLL for a stageless beacon. A stageless beacon is a beacon without a stager. It is the entire beacon inside of that DLL or executable file. When you export a DLL, if you want to start it with rundle32.exe, you can. Just do rundle32.exe, whatever DLL, comma, start W. You may also use Cobalt Strike's web server to host your files. Just go to attacks, web drive-by, host file. And you can upload a file to the team server, and Cobalt Strike will host it on its web server. If you want to manage and remove hosted files, go to attacks, web drive-by, manage. If you want to see visits to your web server, go to view, weblog. All visits to your web server will show up in this tab. Now, Cobalt Strike does have some protection against curious blue teams in its web server. If Cobalt Strike observes a request with a user agent of curl, wget, or links, Cobalt Strike's web server will automatically return a 404 response. Now, let's say you want to use a Metasploit framework exploit to deliver a beacon. You can do that. Here are the steps. Start the Metasploit framework. Pick which client-side exploit you want to use. Next, set payload to Windows Meterpreter, reverse HTTP, to stage beacon with an HTTP stager, or Windows Meterpreter, reverse HTTPS, to stage beacon with an HTTPS listener. You can do this because Cobalt Strike's beacon is compatible with the Metasploit framework's staging protocol. Set lhost and lport in the Metasploit framework to point to your beacon listener. Next, set disable payload handler to true. This will tell the Metasploit framework that it should not try to create a payload handler for Meterpreter. Next, set prepend migrate to true. This option tells the Metasploit framework to prepend a little bit of code to its payload stager that forces the stager to migrate out of the compromised application. This way, if the exploited application crashes, your payload will be able to continue staging and working completely separate of what the exploited application is doing. Finally, use exploit-j to kick off this attack. Let's go pull open a console and let's run MSF console. Okay. Give that a second. Now, let's go ahead and use an exploit. In this case, we're going to use the exploit multi-browser. We're going to use the Adobe Flash Hacking Team exploit. Okay. And we're going to point this particular exploit at our beacon listener in Amazon's Elastic Computing Cloud. And that's ads.losenolove.com, port 80. So let's go back here and let's do set payload, Windows Meterpreter, reverse HTTP. We're not really delivering Meterpreter here. We're just using Meterpreter's stager with this particular exploit. Let's set lhost to ads.losenolove.com and let's set lport to port 80. Next, let's tell Metasploit not to create a payload handler for this attack because we have one already. And let's tell Metasploit to prepend the migrate shellcode to the stager. This forces the payload stager to migrate to another process before it downloads beacon and puts it into memory. This protects us in case the exploited application crashes or the user decides to close the browser. Very good. Now, let's go ahead and type exploit-j. And we now have a Metasploit framework exploit server running that will deliver Cobalt Strike's beacon if all goes well. So we could send this to the target as is. I don't recommend you do that. I recommend you take a step and dress up the attack. One way to dress up the attack is to clone a website and embed this attack into it. Let's take a look at that process. Let's go to Attacks, Web Drive-By, Clone Site. Okay, this is Cobalt Strike's site cloner tool. What we're going to do is we're going to clone a website. We'll clone, for example, google.com. And we'll bind that to /search and host this at ads.losenolove.com. Now, if we had any attacks running here, we could embed those into our cloned site. But instead, we're just going to paste in our Metasploit framework attack. Okay? And this will get embedded into the cloned site as an iframe. So let's go ahead and hit clone. And there we go. We now have a weaponized cloned site that embeds our Metasploit framework Flash exploit. Cool. So let's go to View, Weblog, where we can see the magic happen. Maybe even the beacon stager come in. We'll come over here to Metasploit so we can watch the activity here. And let's go ahead and hook a target. Okay, so let's go ahead and navigate to this malicious site from a vulnerable system. And that's not the one I want to use. It's this one. Okay, so what we're going to do is go to ads.losenolove.com/search, okay, and hit enter. And now there's google.com. You can see in Metasploit there's some activity as it tries to exploit our browser. There you see a get on the beacon stager, and we now have a new beacon. So that's an example of using a memory corruption exploit from the Metasploit framework to deliver Cobalt Strike's beacon. And there's our exploited system right there. Okay, now that we got that fun out of the way, let's go through spear phishing. There's a 4-step process to do spear phishing with Cobalt Strike. Step 1, create a target list. Step 2, create a template or reuse a template. Step 3, pick which mail server to send email through. Step 4, send the message. Let's start out by talking about the target list. A target list is nothing more than a text file with one email address per line. You may also put the actual target's name in the targets file as well. Just separate the email and the name with a tab character. Now, let's go ahead and talk about the template. Cobalt Strike does not let you compose emails inside of the Cobalt Strike client, okay? I'm a firm believer that fishes that are composed in a hacking tool look like fishes that came from a hacking tool, okay? Instead, what Cobalt Strike does is it repurposes existing email messages, okay? There's a number of benefits to that. Once you build up a library of good fishes, you can reuse them between engagements. That's nice. 2, if you repurpose an existing email message, it's going to look pixel perfect like what it's supposed to, okay? And that's more likely to get the user to click, and it's less likely to look suspicious. And that's pretty important. Let's take a look at how to do that. Here's a LinkedIn invitation from a long time ago, okay? And this is what that LinkedIn invitation looks like in a webmail client. Now, most webmail clients and desktop clients give you the option to view message source. If you do that, you're going to see something that looks like this. This is the raw message source. By the way, with no changes, this is your Cobalt Strike phishing template as well, okay? Just save this file and you're ready to phish. If you like, you can update this template by changing it around a little bit, and you can also insert tokens that begin and end with % that Cobalt Strike will replace before it sends a phish. And there are tokens for the URL, there's tokens for the user's name, so all good stuff to personalize each individual phish. Okay, let's talk about the mail server. A lot of folks like to stand up a local mail server to relay phishes for them. In my opinion, this is the cat grep of the red teaming world. When you stand up a local mail server and relay a message to it, here's what that mail server does. It's nothing magic. Or it looks at the email address of where you want to send a message to. And it says, what domain does this email address belong to? It then uses DNS to look up the mail exchanger record for that domain, okay? That's called the MX record. Once it has that mail exchanger record, it connects to that server on port 25 and says, hey, mail server, I have an email for one of your users. Here it is. And the mail server says, hey, thanks, have a nice day. There's a little bit more to it than that. We'll talk about that in depth in part 9. Here's what the phishing dialog looks like in Cobalt Strike. Go to Attacks, Spearphish, and here you can pick the targets file to use, you can pick the template file to use, you can choose to embed a URL, and by the way, whether you use the URL token or not, any HTML links inside of that email will be replaced or will be modified to reference the URL you embed here. You can also choose the mail server, and if you need to, you can configure a username and password for that mail server as well. You can also pick a bounce to address, And this is the address where messages will be sent to if something goes wrong. There's a lot of implications around the bounce-to address that we address in part 9 of this course later on. Let's take a look at phishing with Cobalt Strike. Here we are in Kali Linux, and I'm connected to 2 team servers. I'm connected to a local team server, and I'm connected to a team server in Amazon's Elastic Computing Cloud. If we look at the websites hosted on this EC2 team server, we can see it's hosting a cloned website that is also serving an embedded exploit. Okay, so pretty cool. We're going to phish from this team server though. So let's go ahead and get on with it. First, we need a targets file. So let's go ahead and create a text file and put in our target email addresses, 1 per line. Optionally, you can put in the user's name, just separate it with a tab. Very good. So there's our targets file. Next, we need a template. So let's go over to my webmail, and here's an ad from the RSA conference. Okay? Spam, if I ever saw spam. Let's go to Show Original, and this is our phishing template. It's all we need. So let's go copy that to the clipboard. And let's put it into a file we'll call rsa.template. Paste that in. That's it. That's my phishing template. Okay, cool. Now let's go phishing. Let's go to attacks, spearfish. Let's bring in our targets file. Okay, there's our targets. You can see it parsed correctly. Let's bring in our RSA template. Okay, and we can attach a file or replace the links inside of the attachment with a URL. Let's click ... and we're going to see a list of the websites hosted on all the Cobalt Strike team servers we're connected to. So we're actually going to reference a website on this other team server. Let's go ahead and hit choose. Now we need to choose the mail server to send through. Okay, you can look that up with Dig if you're going to relay through your target's mail server directly. If you have your own phishing domain and you want to connect to your mail server, you can specify the parameters for that right here. I'm going to go ahead and put in the mail server for my local test network, which is 192.168.1.95. And we're going to use test.atattacker.com as my bounce-to address. Cool. Now let's just do a quick preview and see how the message came out. And we could see it stripped out all the headers. And we've got something to Jim Stevens. And we can see, if we look, that many of the links have been replaced. Let's go to the HTML rendering. And we can see that this is looking pretty good. Okay, so we can hover over the different links. And everything's looking good to us. And if there's a text-only format of the message, we could see that as well here. So I think we've got a phish that's ready to go. Let's go ahead and hit close and press send to fire it off. And there we go. Our phish has been sent. Okay. And this here is the output from the mail server. So if there was an error, it would tell us. If there's a queued message ID, that would show up here too. Okay, great. Now let's go ahead and take a look at this phish. First, we're going to watch this team server for any activity because this is where any clicks are going to show up. Let me clear that previous stuff. And let's go over to this Windows 7 system and press refresh. And we see, tell us what you think about cyber stuff. It's cool. hit display images, and we could see pixel perfect fish, okay? Just as easy as that, okay? So to Jim Stevens, and if Jim Stevens happens to click on the message, they're going to be brought to our cloned website, okay, which is actually serving an exploit. And there we go. We get our new beacon. Okay, so that's an example of the phishing process in Cobalt Strike. Okay, now that you've seen how to send a phish, I want to point something out. In this lecture, we've gone through the mechanical process to get a foothold in a modern enterprise with Cobalt Strike. Okay? What we didn't go over was the defenses that could get in the way. Okay? When you're trying to get a foothold in a modern environment with a phishing attack, you have a lot to contend with. First, your message actually has to get to the user, meaning your phish has to look good. You have to avoid any kind of anti-spoofing technologies. You have to avoid spam tells. And you have to get past the mail antivirus gateway. Even if you get the package to the user, you have to have a good pretext to make sure that the user actually opens up the message and takes the action you want. And then you have to worry about the technical defenses that are on their endpoint. You have to worry about antivirus. You may have to contend with application whitelisting. You may also have to contend with a host-based intrusion prevention system. If all that goes well, you'll get code execution. Your payload will now be in memory on the target. But that alone is not enough, because that payload running on the target system has to communicate with you, the attacker, meaning it has to get out past the user's firewall configuration. It might have to go through a proxy that they've set up, okay? And even when that payload's communicating with you, you have to worry that it communicates with you in such a way that an active professional defense team monitoring the network does not find you, okay? Once you contend with that, you've got your positive command and control, and you can go on to do post-exploitation. Now, there's a lot to talk about with each of these wickets. I did not go through them in this lecture because this lecture would become really, really long. If you want to talk about these defenses and get right down to it, I recommend you jump to part 9 of this course when we talk about evasion, because we're going to go through each of these boxes and talk about these defenses in depth, and I'm going to give you tools and ideas you can use to reason about these defenses and deal with them when you use Cobalt Strike. Okay, in this lecture, we talked about client-side attacks, and I went through the client-side attack process I use to get a foothold in a modern enterprise. We talked about the system profiler. We talked about Cobalt Strike's user-driven attacks, and I showed you how to use a Metasploit framework memory corruption exploit to deliver beacon. We also went into spear phishing as well. This concludes part 3 of Advanced Threat Tactics.